provide the value for x, there is this easy way you can just provide the value for x, and that is by making sure the base here is being transferred to this side. And what method are you going to use to make sure that it's being transferred? It is by using what we call the logarithm. So you log the number to the base that you are transferring. So that's how the idea of logarithm comes in. So x is called the logarithm. X is that logarithm that we are referring to. So x is the log. So another name of power of a number is logarithm. X equals the logarithm of b to base a. X equals to the logarithm of b to base a. Alright, logarithm is used. The logarithm used in calculation are normally in base 10, and the name that we call that logarithm to base 10 is this common logarithm. In many occasions, you have your 4-figure table, which is the logarithm table, which has the logarithm table. In Nigeria, we call it 4-figure table. I'm very sure some African countries also use the 4-figure table. We call it 4-figure table. But in many occasions, you have your logarithm table at the back of your text. So conveniently, your textbook producer should have a logarithm table at the back of the text. So you should use it for the course of this class. Alright, the first thing we would like to talk about is how to figure out what the log of a number is, and I would like you to use your logarithm table to provide answer or the log of the following numbers. When we are looking for the log of 3.7, the log of 37, and the log of 3,700. Alright, for the first, which is what? 3.7. 3.7 lies in between 1 and 10. 3.7 is lying between 1 and 10. Why am I telling you this? Because the idea of standard form, if you have a number a times 10 raised to the power n, such that n is a natural number, that is counting number, including 0. So I will include 0. So the numbers are 0, 1, 2, till n. Because we are dealing with positive power for now, so I would like us to use that. So in a situation like that, then this 3.7 is satisfying the condition of a. Because if this is in standard form, then a must be less than or equal to less than 10. And 1 must be less than or equal to 8. So this inequality must be satisfied. So for that to hold for 3.7, then I would say that 3.7 is the same thing as 0. Where do I get the 0 point? It will be 0 point something. Something will follow up. 0 point something. What is that thing that follows up? You will get to know soon. Now, 3.7 in standard form is the same thing as what? 3.7 times 10 raised to the power 0. That is where the 0 comes in. The 0 comes in here. So this 0 that happens to be the power of the standard form of 3.7 is that 0 that I'm going to use there. So 3.7 equals 0 points. Now, how do we go about the something? The something is by going to your 4-figure table and check for the logarithm of 37. If you check properly, you will meet this figure there, which is 5682. So that means the logarithm of 3.7, the logarithm of 3.7 is the same thing as what? 0.5682. Another way of writing this is by saying 3.7 equals to 10 raised to the power 0.5682. Please note that because this class will be very direct. Alright, so let's try to now understand what 37 will be. 37 is the same thing as 3.7 times 10 raised to the power 1. This is what standard form, the scientific method, the scientific form. So this standard form, and we know that 3.7 is the same thing as 10 raised to the power 0.5682, then times 10 raised to the power 1, using your law of indices. Using the law of indices here, we all know that this will change to 10 raised to the power 5.682 plus 1, and you have 10 raised to the power 1.5682. This is telling us, this implies that log 37 is the same thing as 1.5682. So let's do a quick analysis there. When it was 3.5, we have, when it was 3.7, we have our whole number part to be what? To be 0. And when it is now 37, it is like the power of your standard form is the one that is your whole number part now. So try to be relating all these information together, because they are surely going to be needed in this course of study. Alright, let's now move to something more better and stronger. In a situation whereby you are now having problems that are looking more complex, let's look at how to provide the answer to the logarithm of numbers like this, like 37.4 and 3.746. Let's look at these two values. What is surely going to be their logarithm? For the first case, we need to try to figure out that log 37.4 will be 1 point something. From what part? Because 37.4 in standard form is the same thing as 3.74 times 10 raised to the power 1. So what is going to happen there? This one should be transferred. This one should be transferred to that point. So we have that. Then what is the next thing? You are going to know that this is point something. What is now that something? That something is going to be done this way. Follow this instruction. I will read one after the other. To find the something part, that is always called the fractional part. To find the something, you are to go along the row beginning with 37. So you have to go to your 4-figure table and go along the row beginning with 37 and stop at the column with 4 at the top. This gives a figure. The figure that you'll be seeing there is going to be 5729. So which is telling us that log 37.4 is going to be 1.5729. So that is the log of 37.4. And if for the second part, which is what? Log 3.746, this is going to give me 0 point something. I believe you should know the reason why I am having 0 point something now. Because in standard form, 3.746 times 10 is power 0 in standard form. So you just have to transfer the 0 to that position. But before we finish this class, I'll tell you the name given to the 0 part and the something part. So what will you now do to get the something part? That part, you go this way. You find this fractional part, that something part is called the fractional part. You go to the row of 37. Under the column 4, you will find the figure 5729. Then that's not the end. Now find the number in the difference column. What number are you looking for? You are looking for the number 6. You know, this is for column, while this is for difference. This first two figure is what you are going to check for in logarithm table. Then this is always for the column, while this is for the word difference. So the first two figure is for the word, for the logarithm line, while this is under the column that follows. The third figure is under the next column. Then the sixth figure, the fourth figure is always under the difference. So the difference says add 7, because if you check very well, the difference is add 7. On adding 7, you should have 5736. Then that means log 3.746 will be the same thing as 0.5736. 5736. That is how to check your logarithm table. Now, as I promised, I said I will give you the name given to the part of the logarithm. Now, let's assume that you are trying to check for log 3700. This should give you 3.5682. If you cross check very well, you have that. Now, this part is called what? This part is called what? The first part there is called the integer. It's called the integer, or the word characteristics. Another name for it is what? Characteristics. In some textbooks, they call it characteristics. Why this part is called the decimal fraction? The decimal fraction. And why some textbooks call it the word? The mantissa. The mantissa. So you should note that. That is about how to check figure logarithm table. Now the opposite of logarithm is the anti-logarithm, which we will also discuss now. The anti-logarithm. Now anti-logarithm is very simple and direct. So there is also a table created for anti-logarithm. So going to the anti-logarithm table is most of the time is always follow the logarithm table. So in your textbook, I'm very sure you will find it immediately after your logarithm table. Now let's look at a quick one on how to check for anti-logarithm table. Now use the anti-log table to find 10 raised to the power 2.7547. B. The number whose logarithm is 5.3914. And lastly, the antilog of 4.3. I purposely picked this example so that you get to know the different way they can call out antilogs. This is the first way they can twist question on antilog is this. They can just say x equals to 10 raised to the power 2.5471 or wherever the question might be. And this is a way of asking you that you should find the antilog of this. And you should check the antilog table, like the antilog of that 2.5471. So the question that we are dealing with right now is what? So for the A part, we want to venture into the solution. For the A part, 10 raised to the power 2.7547. What you have to deal with is the fractional part of what? 2.7547. Just the what? The fractional part. So what is going to happen? The fractional part is 0.7547. You have to go to your antilog table and check for 75 under 4 difference 7. When you check it properly, as I have just said, you are to get 5684. So you have to check for the word the 75 under 4 difference 7. So when you check this properly, you will get 5.684. Truly, they will not put the decimal point, but I want you to know anytime you check your antilog table, the decimal point is always in between the first and the second digit. So you put it there. Then what's the next thing? You have to multiply it by 10 raised to the power a particular power, and that power is always gotten from your integer. So you have to transfer that figure to the power. So what we have there is going to be what? Times 10 raised to the power 2 lifted from here. So I have 5.684 times 10 raised to the power 2, which is 100, and this is going to 568.4. That is about that. For the second part, which is the second question under this example, you have to find the answer of 5.3914. They twisted the question by saying the number whose logarithm is this. So antilog, the same thing as saying 10 raised to the power 5.3914. So the antilog of 3.3914, you check 39 under 1 difference 4. 39 under 1 difference 4. When you check 39 under 1 difference 4, you should have 2, 4, 6, 2. 39 under 1 difference 4. 2, 4, 6, 2. Don't forget the decimal point is there. So you have 2.462 times 10 raised to the power what? Times 10 raised to the power 5. You lift your 5 to that place. We have that. We have that. So that will be 2.462 times 100,000, and that should give me 246200. That is that about that. And for the last one, I believe you can attempt that on your own, which is like saying checking the antilog of 4.3, which implies 10 raised to the power 4.3. And don't forget, this will be the power of 10 of a particular number, the power of 10 of a particular antilog, which is 10 raised to the power 4 times, then you check the antilog of what? 10 raised to the power 0.3. So antilog of 10 raised to the power that. So the antilog of that is going to give us 1995. Where is the decimal point? It's always times 10,000. This is using 19950. So which is going to be the antilog of that. So this is how to check our logarithm and antilogarithm table. So by the next class, we'll talk about how to use the logarithm and antilogarithm table in running calculation.